Good morning, students. So today I will be discussing in connection with the driving system. So the today's total discussion is about the driving systems which are used on CNC machine tools. So before we proceed with the driving systems in connection with the operation of CNC machine tools, we need to have a review of what we have discussed in the previous session. So in the previous session, we have discussed in length in connection with the anti-friction guideways and what are the different types of anti-friction LM guideways which are going to provide the accurate positioning of the slides, that is the table or the workpiece. So whenever, especially on CNC machines, whenever we want to go for the machining with the help of set of instructions known as a programming, we need to understand that the accurate positioning of the guideways play a very important role as far as the machining aspect is concerned in case of CNC machines. So now we need to understand whenever, because the main function of the guideways is to provide the positioning. So how this positioning is achievable? Just we have discussed in the previous session that we require to position properly the workpiece and we require to position the work table correctly or the cutting tool correctly. Positioning means what? Whenever we want to carry out any type of operation on a CNC machine tool, the workpiece or the cutting tool has to come to the required contact. So when this contacting has to be accurate, and how this motion is given. So the motion is basically given by the driving system of a CNC machine tools. So in order to understand, a very simple definition of a driving system is nothing but one which gives the motion. So that is why we take an example of a motor only, because motor is a very basic element device which is responsible for providing the motion to all these things. Only by using a certain mechanism which converts the rotary into linear. For example, if at all I want to move a work table of a CNC machine, the CNC machine work table is made to move either in X direction or in Y direction. So whenever these directions, that means if at all we don't have the coordinate system arrangement, then it is not possible to write any of the programming instructions also, and we cannot control the table. So when this X and Y direction, whatever I am telling, if at all the positioning of the work table of a CNC machine tool to be positioned in X direction or in the Y direction, okay, then we need to see that it is going to be positioned accurately with the help of a certain mechanism or a certain arrangement through which we are going to convert the rotary motion of the motor into linear motion of the table. Linear motion means what? The motion of a work table either in the direction of x-axis or in the direction of y-axis, or sometimes in the combination depending upon the design of a CNC machine tool. So let us discuss in detail about these driving systems. So driving system is nothing but a motor which is going to provide the required RPM, okay, for a ball screw, which is going to further convert into linear motion of the table. So our topic of discussion in the today's presentation is to discuss about the different types of driving systems used in case of a CNC machines. So as you are going to see clearly on the screen, the driving system consists of two important drives. They are called as the spindle drives and another one is called as a feed drives. So as the name itself indicates, spindle drives basically used for giving the rotational movement for the workpiece, and the feed drives for the work table. That is what we are going to discuss in length in the subsequent presentations. And we are going to discuss in detail about the function of the feed drives. Means drives, when I am going to use the word drive, is nothing but a motor for a simple understanding. But whatever the motors which we are going to adopt, use, are specialized motors, they are called as servo motors or stepper motors. Not like your induction motors, AC induction motors like that, which you already studied in your BEE lab. Now let us understand in the today's presentation in connection with that function of feed drives. requirements of feed drives. That means what are the requirements of the motors which we are going to use, and in that we are basically concentrating on servo motors and the stepper motors in detail in the today's presentation. So let us understand the driving system in a CNC. What I have already explained, the same one is present there. The driving system is an important component of a CNC machine, as the accuracy and repeatability depend very much on the characteristics and performance of the driving system. So we need to understand here that a driving system is a motor alone is not going to provide the required positioning. The motor is going to provide you the rotational movement. Okay, so that rotational movement has to be further converted into linear motion, especially for the table. Otherwise it needs to be controlled by a specialized driving system. That is what we call it as a stepper motor or a servo motor. Sometimes we are also going to call it as a servo mechanism. So because we expect the accuracy and repeatability. Okay, accuracy of positioning means accuracy of rotation of the workpiece depends upon how the motor works. Similarly, repeatability means the same motion is required, because whenever the CNC machine is used for the production of the jobs, it needs to change for every second. It's the motion of the workpiece or the movement of the table. So that is achievable only if our motors are working correctly. The driving system is classified as spindle drives and feed drives. Basically, the driving system, that is nothing but a motor, okay, which is used for driving the spindles and which is used for driving the table. They are named as spindle drives and the feed drives. The spindle drives are used for providing angular motion to the workpiece or the cutting tool. See, this is very, very important. Now the question mark comes. The spindle drives, I am telling, are used for to provide the angular motion to the workpiece. The workpiece has to be rotated to the required rotations correctly, RPM what we call. So let us take a simple example of a lathe machine. In a lathe machine, whenever we are going to hold the workpiece, cylindrical workpiece in a headstock spindle, it is to be rotated, but there the rotation is manual, but means not perfectly accurate to the required RPM, okay, because of various problems like slippage, losses and so many things. So now that should not be the case in case of a CNC machines. So that is why we are going to adopt the servo motors or the stepper motors. So now the spindle drives are used to provide angular motion to the workpiece. Means what? The workpieces are rotated with the help of a driving system known as a spindle drive or a spindle drive motor or a cutting tool. This cutting tool, especially for example, if you take a simple example of a milling machine or a simple example of a CNC drilling machine, in such cases the cutting tools are mounted and they are rotated. So in such cases we are also going to call it as what? A cutting tool driving system. The feed drives are used to drive the slide or the table. Basically the main function of the feed drives is, that is the feed motors, okay, are used to drive the slide or a table. That means it is used for giving the motion to the table or the slide accurately. Even the guideways, whatever are there, they are being placed correctly in the accurate positioning depending upon where the workpiece has to be carried out. The feed drive consists of an electromotor and mechanical transmission system. So we need to understand one important concept here. Whenever we are going to provide the motion to the table, then we need to understand So whenever we want to adopt or use the feed drive, it consists of an electromotor and a mechanical transmission element. Because the motor itself is not going to give any motion, it has to be further converted into linear motion, especially in the case of a movement of a table, because the table is made to move either in X direction or in Y direction. So these X and Y direction is nothing but X and Y axis movement of the work table. That is also called as a linear motion. So which we are going to understand, or you are going to understand in length, especially in the upcoming chapters when we are going to discuss in detail like CNC programming. So let us understand, we have understood now clearly that the driving system is nothing, or the drives are nothing but the motor. This is a very general concept to understand first. Okay, and basically these drives or the motors are used for providing the motion to the workpiece, cutting tool, or the work table. But the work table is not rotated. The work table is always made to move in a linear direction. So for that we require to adopt, or we require to use a certain mechanism through which it is possible to convert the rotary motion of the motor into linear movement of the table. That we are also going to discuss in the subsequent presentations. So now let us understand as a basic concept function of a motor. So we know very important thing. Basically, when the definition of an electric motor is asked, we are going to take the electric current and we are going to convert it into mechanical power or mechanical energy. So basically, when a definition of a motor comes, we require to have a supply of AC or DC and convert that energy into mechanical energy. An electric motor is an electrical machine that converts electrical energy into mechanical energy. Most electric motors operate through the interaction between the motor's magnetic field and the electric current in a wire winding to generate force in the form of rotation of the shaft. So this we need to understand here. So the armature winding is there, and you are going to have a stator, you are going to have a rotor and all that. So where the working principle of the motor plays a very important role, which we have discussed in length, especially in the mechatronics subject. So it is my personal opinion that please go through the actuation systems chapter, which we have discussed in length in connection with the motors. In other words, it is a device used as a final control element in positional or speed control systems. So that is why the accuracy of production in case of a CNC machines basically depends on the selection of the drives, that is called as motors, what we are going to call. So because whatever the accurate positioning is required for the table or accurate rotation of the workpiece totally depends upon the characteristics or the important features of the motors which are used in case of a CNC machines. Now let us understand the very screen itself indicates. Now as we are going to see very clearly, just we need to understand, because here basically you are going to see that we are going to have the one which is going to drive. That one which is going to drive means what? The workpiece is driven here like this. The workpiece is being driven means giving the rotational motion with the help of a spindle motor. So now we are going to convert this spindle motor with the help of a certain mechanical movement where it is given rotational movement only, either belt drive or gear drive, whatever is there, that is requirement. So what we do here, we are transmitting the motion from or the power from the motor to the workpiece. So when this is going to happen, the accuracy of workpiece rotation plays a very important role. For that purpose, we are always going to use the motors which are used for driving the workpiece. We call them as a spindle motor or spindle drives. That's all. Similarly, if you are going to see here below screen, both are same with the names are different, and in both the cases we are going to use the servo motors or the stepper motors only. That you need to understand here. Now this is called as a feed motor because it is responsible for giving the movement for the work table. Try to understand now. The feed motor is rotated and this is called as a ball screw. Okay, and this screw, so this is called as a specialized ball screw, okay, which we have discussed especially in the case of, try to understand in the case of a guideways, that recirculating roller screws etc., where we are going to use especially in case of an anti-friction LM guideway. The same concept is used here also. So what we do here is, this is called as a ball screw, and this, the rotation of the ball screw give the linear movement to the work table. Now the question comes, for example, whenever the speed motor is made to rotate here clearly, the motion is given to the feed motor. The motion is given to the feed motor with the help of a feed drive, then that rotational movement is responsible for moving the ball screw, and due to rotation of the ball screw there is a linear movement for the work table. But this movement is only in one direction. So whatever figure you are going to see, that this is only a basic working principle concept, how we are going to use the motors for conversion of rotary into linear. So this can be for x-axis. Now I want to go for y-axis. Okay, the same principle is used for giving the movement. That means each axis are driven by different motors. Now for example, this can give a movement in x direction, then one more motor I require to use which can give the motion to the table in the y direction. So basically we need to understand here, it is a basic concept where we are converting the rotary motion into linear motion, especially in the case of the CNC feed drive mechanism, which you are going to see clearly on the screen there. The various drives used in CNC machines can be classified as the spindle drives to provide the main spindle power for cutting action. That is very, very important. Even this cutting action is also carried out by the spindle drives, and the feed drives to drive the axis, because here our intention is to give the movement to the work table in different axes. That is why we call it as feed drives to drive the axis. That is very, very important concept to be understood. Now let us understand in detail about the working of spindle drives. The spindle drives are used to provide angular motion to the workpiece or a cutting tool, which we have discussed now. Just in brief with a sketch, these drives are essentially required to maintain the speed accurately within a power band, which will enable machining of a variety of materials with variations in the material hardness. So whenever I am going to tell about the drives, we expect certain qualities, certain features from the motors. So that is why within a power band means which is responsible for the accurate positioning, which is related to the characteristics of a motor. Okay, for as far as the machining of different materials is concerned, with the variations in the material hardness, the speed ranges can be from 10 to 20,000 rpm. Nowadays you are going to have more than that. This is the old concept definitely as given in the book. So try to view some of the important videos related to spindle drives. The speed ranges can be from 10 to 20,000 revolutions per minute. The minimum range can start from 10 rpm, so much slow, and to the highest speed, because this requirement is not achievable if at all we adopt the regular motors or continuously rotating motors which are studied in induction motors like that. The machine tools mostly employ DC spindle drives. In case of a machine tools, because of certain advantages, there is a more adoption of DC motors are used, but as of late the AC drives are preferred to DC drives due to the advent of microprocessor based AC frequency inverter. So what we are going to do here, because of the development of in the field of an electronics, we can adopt the AC frequency inverter, and using that principle it is possible to use the AC servo motors also, because they can be controllable with the help of a microprocessor system. Okay, and high overload capacity is also needed for unintended overloads on the spindle due to an appropriate feed. So whenever the high load is coming, especially on the cutting tool, or high rotational speed requirement is required, then it should have a capacity for the motors to provide such an irregularity or the continuous changing rotations. It is desirous to have a compact drive with highly smooth operation. Even whatever the spindle drives which are used on CNC machine tools, they should be a very compact one. They should not be a very large, having a massive weight. Okay, it should be a compact one, and it has to provide the excellent speed regulations as per the requirement. So that is the basic understanding about the spindle drives. Now let us understand in brief about the feed drives. The feed drive is one of the most important parts of every CNC machine tool. So we know that whenever I want to give the movement to the work table, then I'm going to adopt the feed drives. The feed drive main purpose is to move the workpiece parts of the machine tool, work table, tool unit, spindle unit, etc. through machine axis. So just I have discussed that whenever I want to give the motion to the machine table, then we are going to adopt the feed drive mechanism. A separate feed drive is necessary for every machine axis. This we need to understand, that means suppose if the table has to be made to move in x-axis linearly, then we require to have an x-axis feed drive, means one which can give a motion, okay, rotational motion with respect to the x-axis. Similarly, y-axis with respect to y-axis, like that. Okay, number of axis. Okay, how many axes we require? So many drives or the motors are required to be used for giving movement to the work table. A feed drive consists of a feed servo motor and an electronic controller. It is having an electronic controller, and it is also going to have a an feed servo motor and an electronic controller. This is very, very important. That means whenever because we are transmitting the motion from the servo motor or the stepper motor, okay, that rotational movement is converted into linear motion. Again, that linear motion, okay, the feedback is taken back and it is sent back to the controller for checking whether the table has moved to the required linear motion or not, which we have discussed in length while discussing about the closed loop. Try to understand the closed loop control system. We start from the sensor, some error, control system, correction element, then we are going to take the feedback, comparison is done, some corrective action is taken. So that is called as a closed loop. That itself is nothing but an electronic controller system. Unlike a spindle motor, the feed motor has certain special characteristics like constant torque and positioning, because see, in a spindle drive, means a spindle motor, it will do, because just we are going to use a rotational movement. If it is going to provide that accuracy of movement, we can use. But whereas we expect more important features from the feed drives, that means whatever the motors which we are going to use as feed drives should have better characteristics compared to the spindle drive motors. Okay, now what are those characteristics? Constant torque and positioning, because the positioning of the work table plays a very important role. That is why it should be able to respond properly as a constant torque and positioning of the work table. Now the same figure which we have already discussed in length in the previous session, I don't think is necessary to discuss about that concept. Now we understood that we expect more characteristics, better characteristics from the CNC feed drives. That means the motors, the servo motors, which are used for driving the ball screw, in turn for giving the linear movement to the work table, should have these requirements. Then only it can satisfy the accurate positioning. Accurate machining is achievable on CNC machines. High torque to weight ratio. We require to understand here high torque to weight ratio means, suppose if I take this high, basically the whatever the torque is there is again related to your rotational movement, power requirement, etc. Now it should have a high torque to weight ratio. If I take that ratio, it should have high. Okay, low armature or motor inertia. That means, you know very well, whenever the signal is going to come or the pulses are going to come from the controller unit, the feed drives, means motor, should respond quickly, as good as, that means it should not have a high inertia for giving the rotational movement. Low electrical and mechanical time constants, permanent magnet construction, these are the very important. Permanent magnet type of motors are commonly used. Okay, maximum speed up to 3000 rpm it has to provide. High peak torque for quick response. This is very, very important. It should have a very quick response. The required constant torque for overcoming frictional and working forces must be provided. So these are considered as very, very important CNC feed drives requirements. That means we expect from the servo motors or stepper motors of the which are used for driving your work table. Now let us understand, which I have already discussed in length for better understanding. Again, try to recollect yourself even from the mechatronic system. Now what we are going to do here, very clearly. The figures show very clear instruction is there how we are going to give the motion to the work table on a CNC machine. Very, very important. So let us understand that we are going to take a motor here. As you are going to see the components of servo mechanism, first we take the motor, okay, and then that motor rotation is given to the lead screw rotation. As you are going to see here, instead of lead screw here we are going to use the ball screw here. This is called as a ball screw, or the same one is nothing but a lead screw itself. So what we are done here, we are going to have a motor, then we are going to convert that rotary motion is given to the lead screw, then the table will start moving. So to have a simple understanding, the table is going to act like a nut and this is going to act like a screw. Then it is sensed by the encoder. It goes to the encoder, it goes back, this movement is fed back to the encoder for corrections to be made. Okay, feedback is given and motion speed is controlled. So this is how the feedback loop, closed loop, which is used for giving the accurate positioning of the work table. Now whenever this conversion is going to take place, the linear motion is also given in the here system, as you are going to see the rack and pinion arrangement. The motion is given to the pinion and the table is made to give the linear motion. So this particular concept we call it as a servo mechanism, how the table movement is given with the help of the drives or the motors in case of a CNC machines. Now let us understand in brief about the classification of servo motors. So the servo motors are basically classified into three types, that is AC servo motor depending upon the type of current that we are going to use, DC servo motor and brushless servo motor. This is very, very important. Now our concentration is basically on AC and DC servo motors. Servo motor differs in application capabilities from large industrial motor in the following respect. They produce high torque at all speeds including zero speed. Try to understand, because every moment the CNC machine expects for the workpiece to be rotated at different rotations depending upon the machining operations to be carried out automatically. So that is why they are having a high torque at all speeds including zero speed. They are capable of holding static, there is no motion position. They do not overheat at standstill or lower speed. So why we are going to use the servo motor that we are discussing here? They are not going to be overheated even if the CNC machine is used for 24/7. That is the main excellent feature of these servo motors. Due to low inertia, they are able to reverse direction quickly. As the inertia is low, no, so that is why we can reverse the rotation clockwise as well as anti-clockwise rotation can be given at ease, and this is going to happen as per the programming instructions stored in the CNC machine. They are able to accelerate and de-accelerate quickly. So that is very, very important. That means whenever it is going to receive the signal from the controller unit, it is going to respond very quickly, meaning of that. Now let us understand the feed motors. Now we are going to focus on the feed motors for the CNC machines. So the feed motors are basically classified, which are going to be commonly used on CNC machines. They are called as servo motors and stepper motors. So depending upon the construction, we are going to consider as DC servo motors and AC servo motors. But whereas in case of a stepper motors, they are permanent magnet, variable reluctance and hybrid synchronous stepper motor. So these concepts also we have discussed in length in the subject of mechatronics in actuation systems. So try to recollect yourself, okay, and try to understand the better in connection with the working of this. Now let us understand in brief about the DC servo motor, okay, that is what we are going to discuss here. So here you are going to have, this is the most common type of feed motor used in CNC machines. The principle of operation is based on the rotation of an armature winding in a permanently energized magnetic field. You are going to see the magnetic field here, which is produced by the permanent magnets. Okay, and the coil is also given a motion here, which you are going to see very clearly there. The armature winding is connected to a commutator. Observe it carefully. Where is the commutator? You are going to see very clearly here. Commutator, which you are going to see very clearly here. Commutator. Okay, and the armature winding is connected to a commutator, which is a cylinder of insulated copper segments mounted on the shaft. It is mounted on the shaft. The DC current is passed to the commutator through carbon brushes, which are connected to the machine terminals. The change of motor speed is by varying the armature voltage, and the control of the motor torque is achieved by controlling the motor's armature current. So the entire functioning is based on the, as you are going to see here, we require by varying the we require to pass the DC current, or that means we require to use the DC current here, which you are going to see clearly here. Okay, then in order to achieve the necessary dynamic behavior, it is operated in a closed loop system equipped with sensors to obtain the velocity and position feedback signals. So as I have told that we require to understand one principle here as far as the working principle of DC motor is concerned, that we require to take the motion back from the motors for giving any corrections with the help of a controller unit. So that is the how the DC motor is going to, servo motor is going to function. Now let us understand, as the name itself implies, AC servo motors. So in an AC servo motor, the motor is a permanent magnet, while the stator is equipped with 3-phase windings. The speed of the motor is equal to the rotational frequency of the magnetic field of the stator, which is regulated by the frequency converter. AC motors are gradually replacing DC servo motors. The main reason is that there is no commutator or brushes in AC servo motor, so that maintenance is virtually not required. In AC motors, we are not going to use the brushes here. Okay, no commutator or the brushes, a very important concept. Furthermore, AC servos have a smaller power to weight ratio and faster response. So compared to DC, AC servo motors are going to have an excellent response. So our concentration is again more on stepper motors. Okay, a stepper motor. So this I think we have discussed in length, especially in the mechatronics subject. So as the name itself indicates, that these motors are made to rotate for each pulses, okay, to a minimum of angle of 7.5 degrees, which we have discussed if you are able to recollect yourself in the considering the actuation systems in the mechatronics. So we need to understand here that the stepper motors is going to be rotated as per the electronic pulses generated from the controller unit. So how many pulses will come? According to that, there is a movement of the rotor, okay, and it is responsible for giving further linear motion to the work table. A stepper motor is a pulse driven motor that changes the angular position of the rotor in steps, and it is going to be rotated in steps for accurate positioning. That is very important here. Due to this nature of stepper motor, it is widely used in low cost open loop position and control systems. So it can be used as an open loop also. It's having a low cost. And in types of stepper motors, permanent magnet is the most common type, because in permanent magnet we are going to have employ permanent magnet, low speed, relatively high torque, variable reluctance, does not have permanent magnet, or low torque. Okay, the variable reluctance, it is not having a permanent magnet. I will just repeat it. In types of stepper motors, one is permanent magnet type, one is a permanent magnet type, another is a variable reluctance type of stepper motor. So in a permanent magnet type, it is going to use permanent magnet and it is relatively low speed and relatively high torque. But whereas in variable reluctance does not use the permanent magnet and it is going to have a low torque here. That is very, very important. Okay, in the stepper motor, A stepper motor is a device that converts the electrical pulses into discrete mechanical rotation motion of the motor shaft. Just we have discussed in length that the main function of the stepper motor is to take the pulses and convert that rotational movement into linear motion of the work table. This is the simplest device that can be applied on CNC machines, since it can convert digital data into actual mechanical displacement. Now you are going to see here, this is another view which we are going to discuss here. This is called as a stator, and these are called as the poles, which you are going to see here. These are called as the poles, and this is the rotor. Okay, and this is always of a permanent magnet, and these are called as the windings. So that is what this is, the cross section which we have taken parallel to the shaft. Suppose if I take parallel to the shaft, how it looks. Stepper motor, stator has a winding made of concentrated coils on distinct poles. Okay, stator is having also the windings. Rotor has a permanent magnet cylinder. Rotor is having it's of a permanent magnet cylinder. The stator windings are inserted on the periphery of the yoke, and this is slide on the permanent magnet pole cylinder. The rotor shaft is located at the inner center of the yoke, mounted on the bearings. Okay, examples of stepper motors applications where they are being used: magnetic head of the floppy disk drive, hard disk drive of a computer, daisy wheel type printer, which we have discussed in length while discussing about the types of printers like laser printer, dot matrix printer, etc. XY tape control, and CNC EDM wire cut machines. So these are the applications where the stepper motors can have. Just observe the working for few seconds, so then you can have how the arrangement is there for the stepper motors. Just you can have a view there which is charged. See, there is each and every stator coil is getting charged there. Just observe carefully. Okay, which is a green one. The green indicates the charging, and that is responsible for giving the rotational movement to the rotor, which you are going to see clearly there. The same one which I have discussed is also shown here. So whatever you are going to see here, you are going to see clearly here, and here the constructions, how the working is going to take place. That is very, very important. So now let us go to the stepper motors, the same one which you are going to see. Just I will read out for in detail about the stepper motor. The top electromagnet 1 is turned on, right? Just observe there, it is turned on now. Yes, it is turned on now. Okay, attracting the nearest teeth. So whatever the nearest teeth is there, that nearest teeth is attracted, and the motion is given. The nearest teeth of the gear shaped iron rotor with the teeth aligned to the electromagnet, that is, they will be slightly offset from the right electromagnet 3, as you are going to see there. The top electromagnet 1, this is called as the top electromagnet 1, okay, is turned off. It is turned off now. It is red, means it is a turning off, and the right electromagnet 3 is energized. Right is energized when this portion becomes off, this gets energized. So that is why it is going to give a responsible response for giving the continuous rotation in the form of a steps. That is very, very important here. Okay, the top electromagnet 1 is turned off, and the right electromagnet 2 is energized, pulling the teeth into the alignment with it, this resulting in a rotation of 3.6 degrees. In this example it is shown like that. Okay, the bottom electromagnet 3, which you are going to see, is energized. Another 3.6 degree rotation occurs. Okay, the left electromagnet 4 is energized, rotating again by 3.6 degrees. When the top electromagnet 1 is again enabled, the rotor will have rotated by 1 teeth position. Since there are 25 teeth, okay, it will take 100 steps to make a full rotation in this example. So as you are going to see, that means for the complete energizing of all this can give a motion of only 1 teeth rotation. That means that is why it is called as a stepper motor. So try to understand it clearly there, how a stepper motor is going to work. Now in the today's session, the frequently asked question just I am considering here. List the commonly used feed drive motors for CNC and machines and explain DC servo motors. You require to just enlist and also try to understand the working principle of them for better understanding of the today's presentation. So along with this, I am going to conclude the today's presentation. For better understanding of the concept, visit some websites in connection with that and try to recollect yourself what we have discussed even in the mechatronics course, because there also we have discussed in detail about the stepper motors and servo motors and their different types, especially in the chapter of the actuation systems. So with this, I am going to close the today's presentation and everybody has to answer the assessment question.